Hello, Math 1680 student. I got a question from a student about this homework set, exercise set number 4, and it was about the Venn diagram problem. However, I do not want to exhaust this problem set, so instead of answering the questions with this problem set, I'll do this. Let's go to an exam problem I wrote recently. I wrote it in summer of 2020, and let's go to problem number 2. There's a very similar problem here. Basically the same Venn diagram here with 3 sets, and then we have of course different numbers, different environment, and then if you go over to individual problems, these are similar. Not exactly the same, but similar. So that's what I'm going to do. And the students who are already done with exercise set 1 number 4, please regard this as an exam preparation. Okay, let's go to this problem set. Here we go. An electronics store recorded recent sales for 3 types of popular software: games, educational software, and utility programs. In a survey of 893 customers, 545 purchased games, 497 purchased educational software, 290 purchased utility programs, and so on. So what can you do about this? You can start a Venn diagram and you can begin putting numbers in. So total of 893, that's gonna be the entire box, the square. So put 893 somewhere here, just outside or on top. Okay, so far so good. And then 505 purchased games, so 545 here, and 497 purchased educational software, 497 here, and 290 purchased utility programs, 290 here, and so on and so forth. If you do that, you may end up with something like this. Like this. Does it look good? Well, let's see. 545 purchased games, 497 purchased educational software, 290 purchased utility, and 297 purchased educational software and games, so it goes in the middle. 196 purchased educational software and utility program here, and so on. Does it look good? And then if you want to find out how many people purchased neither, okay, all right, the total is 893. So if you add all these up and then subtract from 893, you're going to get the people who are not counted in any of those. But then again, you're going to feel a problem here. If you add up these numbers, that'll exceed 893. So what's wrong? Many people were counted double or triple. For example, 545 people who purchase games include not just those who purchase games, but people purchase game and educational software. These people are counted both for 545 and also 497. And how about these people? 196 purchase educational software and utility programs. So these people are counted in this 497 and this 290. So many people are doubly and some people are triply counted. And of course there are some people counted only once. So how do we separate all those and get those right numbers? Certainly this is not working. This is how to get it wrong. So the answer is no, this doesn't look good. So how do you work it out? My suggestion is to work backward. It is best to work backward. Among all these numbers put in, you see, among all these, there are exactly 2 numbers that are correct. One is, of course, 893. That's a grand total, so that's obvious. The second is not as obvious, but still it's easy to see. Among all these numbers, only one number is correct. Okay, counting 893. Two numbers are correct. What's the other correct number? It's this one, 157. 157 purchased all three types. So right in the middle, covered by all the circles, inside G, inside E, inside U. So that's the starting point. Okay? And then let's backtrace the problem. Let's work backward. This one first. 157 purchased all three types. Okay? All right. There you go. Next, let's figure out the people who would go in these overlaps. What do I have? 205 purchase games and utility programs, and then 196, and then 297. Let's take care of these people one at a time. That's the next step. Okay. Let's get this Venn diagram. This is the intermediate stage. Okay, this is what we have so far. Okay, 157, that's done. Now let's work on this blue part. 205 purchase, utility, and games. That's a game circle, and that's utility circle. Inside, we have this football shape. Among this football shape, 157 are already counted. You see, there are 205 people inside this football. I'm running mouse around. 157 already here. So that part will be what? 205 minus 157. So there are only 48 people here. The total is 205. 157 is here. Here, 48. Make sense? How about the red part? 196 purchase educational software and utility. Utility and educational, so it's this football here, inside the U and inside E. But among 196 total, 157 already counted. So what's the subtraction? 196 minus 157. So that's going to give me 39. Makes sense. So 48 here, 39 over there. How about the green computation? I'll give you a little bit of time to figure this one out. Something minus something. Well, time's up. Here's the answer. And that's what we have. You see, first subtraction blue, 48. Second subtraction red, 39. And then third subtraction green, 140. They correspond to blue, red, and green information. We're backtracing the problem, okay? This one we did earlier, previously, in the middle. And then we are going to the second overlap, blue, red, green, in that order. Well, these three order, you don't really have to follow precisely, but if I simply backtrace, usually I can't miss it, so I like to do it this way. If you mix up the order among those overlaps, actually that's going to be fine. It's just that there is a bit of a danger of missing something. Okay, this is what we got so far. And then let's move on to the next stage. Keep backtracing. Keep backtracing. Okay, 157 we covered. And then these three, blue, red, and green, we covered. Next. 290 purchased utility program, so some pink over here. So how do you do that? Utility program, this entire circle has 290 people. See, I'm running mouse around. That entire circle has 290. But among them, some people are already selected. 48, that's counted. 157, that's counted. 39, that's also counted. Is 140 counted in? No. 140 doesn't belong to this utility, so it's out of consideration. Among this utility, 48, 157, and 39, those people are already counted. So subtract out, I'm going to get 46 people right here, where my mouse is right now. 46. Those people purchase only utility programs, no game, and no educational software, just utility. So that number, which I'm highlighting in pink, magenta rather, that's going to go to 46 right over here. You have two more to do. Education only, brown, and then 545 purchase game, game only, purple, brown and purple. You have to do similar computation. Can you do that? Maybe you can stop this recording and do that on your own. Assuming you did, let me show you the answer. And here we go. So out of 290, I subtracted away the people already inside this utility circle, counted already. And then education, the total is 497. Among these, 140, 157, 39, they are all counted already. So subtraction will give me 161. That's brown. And then purple, or some maroon color rather, 545. Among those, 140, 157, 48, they are counted. The total here, this circle is 545. So the subtraction yield 200 right here. So I'm almost there. One more backtracing. Total in a survey of 893. So 893 goes over here. And then the total is 893. And then we have all these numbers. Now all these numbers are correct. So subtracting all those numbers from 893, I'm going to finally get the people who are not counted in any of those three. What did I end up with? I ended up with 102 people who are not counted in any of these three circles. So those three peoples purchased none of these three. No game, no educational software, no utility. Maybe something else, like purchased some DVDs or, come on, that's too old school. Maybe purchased 3 terabyte the memory, something, whatever. It's not software, so, oh, never mind, whatever. Whatever that are not counted in those G, E, or E. Okay. So we're going to use this circle, this Venn diagram, to answer all these questions. Now the preparation part is done. Let's go to the problem set. If you select a customer at random, what is the probability that the selected customer bought none of the three types? So we are talking about these people. 102 out of 893. It's an easy computation. 0.11 something. Okay, next. Same Venn diagram. If you select a customer at random, what is the probability that selected customer purchased games and educational software, but no utility. Let's see, this is a logic question. Game and educational software. Game and educational. So game inside G and inside E. So we're talking about only these 140, 157. Okay. Where the total will be, let's see, 297 games and educational software. But among those in this football region that I'm running my mouse around, but no utility. Okay? In this football, outside U. So which is it? Which number is it? In this football, no utility. Is this it or is that it? It's 140. But not U. 157 is inside U. So those people purchase all three. Game, educational, and also utility. Okay, next problem. Games or educational software, but no utility. Now, what's the difference between the previous problem and this? It's and versus or. So it's a logic question. Or is basically adding more. This is okay, or that's okay, even that is okay. You can just add all those. And is different. And is small. You have to find out the people who purchase both G and E, so only the inside. But G or E, these are okay. 200 people. These 161 people are okay. Of course, these 140 people are okay too. How about these 48 people? How about these 157? How about these 39 people? If I'm looking at only those purchase games or educational software, the answer is yes, yes, and yes. But here's additional condition. No utility program. So 48, 157, 39. No, those people purchase utility, so no. So no utility, so that's out. So what do we have left? There's 200, 140, 161. Divided by the total of 893, we have the desired probability. Okay, let's go to the final question. And the final question here doesn't have anything to do with the Venn diagram. We're selecting now not just one, but 3 customers. What is the probability they all purchased a utility program? So utility program, 290. So if I select a person at random, what is the probability the person purchased utility program? Is 290 over 893. But that has to be repeated 3 times. So if I select just one person, it is about 0.22 something. Now, depending upon how you set up the problem, you can consider 2 types of problem. Those 3 people may have been selected with replacement. Select a customer out of some pool, and then put that back into the hat, or from the same database, select another, and then from the same list of names, select a third person, which means there is some chance one person is selected twice or 3 times. Rare, but that's possible. In that case, the first and the second and third are exactly the same. We just multiply them. No, it's this one with replacement. Now, if we have to exclude those, a bit of a typo here, this should be second. In that case, out of 196, well, one person is selected. So next we go down to 195, and then we go down to 194, and the total also go down, 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 because we're selecting people and those people are excluded. So that's for without replacement. Will that make difference? If you have some like bowls and urns and we have some 10 bowls or 15 bowls, yes, with replacements or without replacement will make significant difference. Select a bowl from an urn, record its color, and then put it back in, reshuffle it, and take it again. And then, play some Scrabble game. You start with 100 tiles, but as the game goes on, the probabilities become different. For example, toward the end of the game, you may run out of all use. But then again, this is a little bit different. Each time is new. Each time, same as before. You're simply selecting a name from a database. You're not changing the database. So what's the difference between this and that? Numbers of course are a bit different, but look at the numbers. Numbers are very similar and not a whole lot of difference. Meaning, out of 893 people, selecting one and dropping down to only 892, that makes very little difference. So if you have a sample of 1,000 or more, with replacements or without replacement, that'll hardly make any difference. Why am I talking about these with and without replacement in such a detail? Because this is what we do in practice without replacement, because we don't really give one person double, triple chance. This is practice. This is what we actually do. But all the mathematics that we are going to learn in this course is based upon this. Instead of actually selecting people and then getting people involved and then talking to those people, which can be really time consuming or sometimes impossible, we just deal with a database, much cheaper and always accessible. So this is far more effective in terms of, the actual working. But this is the real event. So how do you use theoretical probability computation we do in classroom to predict or simulate what's really going to happen? As you can see, the difference is relatively small, and that's because the sample size, 893, is sufficiently large. Now, if you have something larger than 1,000, then difference will be really pretty negligible. Of course, if you go to some Gallup website or Pew Political Studies and Politico, whatever, if you go over to any kind of polling, I don't think you'll find any kind of sample less than 1,000. So all those kind of things that people do in practice actually stem back to this distinction. So if you go to this problem alone, then I'll simply say either way you're going to earn full credit. But if you want to know why we are distinguishing one and the other, and then still counting both of them as correct answers, well, I told you all about those already. So this is the actual event that's going to take place. And this is mathematical simulation that we do. And we want them to be similar. And how do we make them similar? By taking large sample. Okay, so much for this problem set and so much for background. Thank you.